Hi friends, welcome back to Edupedia world. Today we'll continue with our discussion on electromagnetism and specifically on electromagnetic induction. One of the applications of that. We'll study about transformers today. We'll see what is the construction, principle and working of a transformer. We'll see the two types of transformer, namely step up transformer and step down transformer. Step up transformer is used to increase the voltage. Step down transformer is used to decrease the voltage. We will see how that is done. And finally, we will conclude the lecture today and the whole chapter of electromagnetism by seeing uses of transformer. So let's get started with today's lecture. In our household, not all appliances work at the standard supply voltage, that is at 220 volts. We have different appliances which either require the voltage to be much higher or the voltage to be much lower. For example, the doorbell might require something like 6 volt or 12 volt, whereas television set requires much higher voltage in the order of several kilovolts. So how exactly does we take care of this? Since the supply is a constant supply of 220 volt in the AC format, how do we either reduce the voltage or we increase the voltage? This task is done by what is known as transformer. Now, transformer can be defined as a device which alters the amplitude of EMF. Okay, that is, it can either increase the amplitude of EMF or decrease the EMF. So basically, if the input supply voltage EMF varies like this, then either the transformer will increase this or it can decrease the value. Now you might have noted that here I have drawn all the three of same frequency. What this means is that a transformer, though it changes the amplitude of voltage, this is the voltage, it does not change the frequency. So the transformer lets the frequency remains the same. The input frequency for your household is 50 Hertz. A transformer can either increase the voltage from 220 volt or decrease it from 220 volt, but the supply remains 50 Hertz. So that is an important thing that relates with transformer, that it does not change the frequency. Okay, with this background, let us see the principle on which transformers work. Transformer basically works on the principle of electromagnetic induction. Electromagnetic induction. We will see in details while discussing the working, how does electromagnetic induction come into play for a transformer. But the basic idea is that a transformer consists of two coils. One is a primary coil and second is a secondary coil. And the primary coil, let me show a rough drawing. Something like this. So the primary coil will have the voltage supply. So this is my supply, and the secondary coil on the other end is my output. and this is the secondary coil. So what basically happens is that the primary coil induces an electromagnetic force via the supply, which continuously changes, and that changing electromagnetic force or magnetic flux is transmitted here. Since the magnetic flux is continuously changing, that results in a electromagnetic force being generated at the output, and basically we get a output EMF. But how does this either increase or decrease the voltage, that we will see in the working. Before that, let us see what is the construction of a transformer. So a transformer is basically consisted of a soft iron core. Okay, soft iron core, and the soft iron core is made up of several plates of iron, soft iron, which are laminated from one another, separated from one another, and they are normally in the shape of a T or U shape. So basically what will happen is there will be each soft iron core will be something like this. Okay, and each one is laminated either using a paint. Each plate is laminated either using a paint or sometimes varnish. These plates are placed together, which are laminated from each other, placed together to constitute the core of a transformer. Okay, so that is our basic construction. Now the input end, that is the supply end, will have copper wires here, and the output end will also have copper wiring, which will lead to the output. But the supply end will have Pn. Supply end is called the primary end. Np, number of coil revolutions, whereas the output or the secondary coil will have Ns, number of coil revolutions. Okay, now these are very important factors. Definition of turns ratio, also denoted as N, is number of turns in secondary coil by number of turns in primary coil. Therefore, turns ratio can alternatively written as Ns upon Np. Turns ratio is a very important concept, which we will see why it is so important. So remember this. Now we have seen the construction, we have seen turns ratio. There are some points to note about the construction. One thing is, why the laminated core? The laminated core basically reduces loss of energy due to eddy current. That's why lamination. Let me write it down. Reduce eddy losses. Okay. Second is that the advantage of closed core, the whole core is closed, is that it gives a continuous path for the magnetic field. Therefore, all the magnetic field or all the magnetic flux developed from the supply side or the primary side passes through the secondary coil. Thereby, maximum output can be derived from the secondary coil. And finally, we have the core made up out of soft iron. Why so? Because soft iron has high magnetic permeability and hysteresis losses is reduced. You need not know in exact details what it is, but what this means that different losses are reduced. Okay, Now that we have seen the construction, let us see how exactly the transformer comes into play. As we discussed here, that the supply side has a AC current supply, isn't it? Now, what is AC current? It is alternating current having continuously varying voltage. Okay, as a result of that, there is a continuously varying magnetic field. Now, that magnetic field or magnetic flux is associated from the primary side to the secondary side because of the magnetic core or soft iron core, and with change in the magnetic EMF in the primary side, the flux continuously changes, and that associates with the magnetic flux changing on the secondary side. As a result, EMF is developed on the secondary side too because of the changing magnetic flux, right? So here comes into play the electromagnetic induction. The magnetic flux changing in the primary side results in changed magnetic flux in the secondary side, results in induced EMF being generated. Okay. Now for a transformer, the induced EMF and the supply EMF relates to the turns ratio. How so? Let me write it down. Let me write it as EMF in the secondary side upon the EMF in the primary side is equal to the number of turns in secondary coil by number of turns in primary coil. That is equal to Ns upon Np, which is our turns ratio N. Right? From here what we can see is that the EMF induced in the secondary coil, that is the output which we will receive, is equal to the EMF in the primary coil times the turns ratio. So larger is the turns ratio, more will be the output EMF. Smaller the turns ratio, less will be the outer EMF. This is the fundamental of either step up transformer or step down transformer. Okay, so what we are doing is, in step up transformer we are providing more number of turns in the output side, thereby the turns ratio is more than 1, and EMF in the secondary coil becomes more than EMF in the primary coil, thereby the voltage is getting stepped up. In the case of step down transformer, just the opposite is happening. That is, the number of turns in the primary coil is more than in the secondary coil, thereby the turns ratio is less than 1, and the EMF in the secondary coil will become less than the EMF in the primary coil, thereby reducing the output voltage. Okay, so this gives you insight about how to either increase the output voltage or decrease the output voltage. Now, one important thing to note is that the power input will be equal to the power output if there is no losses. We are considering no loss scenario. Okay, so power input will be equal to power output. Now, what is power? Power is equal to V times I. So V primary times I primary is equal to V secondary times I secondary. Therefore, what we see is that in a step up transformer, that is a transformer in which Vs is increasing, the current has to reduce. In a step down transformer where the Vs is decreasing, the current will have to increase. Okay. Now a larger current means thicker wire is required in order for any avoiding of overheating. Therefore, in a step up transformer, since the output, the secondary coil will have higher voltage, the current will be lesser in that, therefore the primary supply end should have thicker wire. In the case of step down transformer, since the voltage of the output is less, therefore the current at the output end is more, therefore the output end or the secondary coil should have thicker wire. Okay, I hope you get this concept. This is a very important practical concept in designing a transformer. Okay, so now we have seen what a transformer is, its construction, what is turns ratio, what are step up and step down transformer, and how does voltage and current relate by equating the powers. With this background, let us see some of the uses of a transformer. Now, as we have discussed, transformer comes in two categories. One is step up transformer, where we increase the voltage. Other is step down transformer, where we decrease the voltage. So what are the prospective uses of a step up transformer? Let's discuss. One very important use, as we have already seen, is while transmitting electricity through long distances from the power station to the household usage, the current is increased, rather the voltage EMF is increased. So there we need a step up transformer to step up the voltage or the EMF. Second, in our household, the television, the cathode ray tube works at quite high voltage in several kilovolts. So we need a step up transformer there. Also, different X-ray tubes in practical applications in laboratories, we need step up transformer. Now, where are step down transformers used? Step down transformers are used basically in, let's say, night bulbs. They work at lower voltages, so we need to step down the voltage. Your mobile charging are normally at 12 volts, so you need to step down the voltage for mobile charging. The charger of mobile has the transformer inbuilt in it. Also, in the substations, we need to step down the voltage from the very high 132 kilovolts to 33 kilovolt, or from 33 kilovolt to 11 kilovolt, and again in the local substation from 11 kilovolt to 220 volt. So these things are done using a step down transformer. Okay, now that you have seen the whole concept of transformer, let us discuss one small numerical to elaborate the theory of transformer. Let's say that we have an input supply of 220 volts, and let's consider two cases. One case where I need to increase this 220 volt to 11,000 volt, and another case where I need to reduce the 220 volt to, let's say, 22 volt, just for simplicity of calculation. Now you are said that the supply end of the transformer or the primary coil of the transformer has 100 turns. Okay, now you need to find the number of turns in the output or the secondary coil of the transformer for case 1 11,000 volt and case 2 22 volt. To do this, either you can think logically that since we are stepping up, in the first case we need to have more turns in the secondary coil, and how much more? 11,000 divided by 220 more, that many times 1000. But alternatively, we can do it directly by using the formula. Let's do it using the formula. The output EMF, let me write it first. EMF secondary upon EMF primary is equal to N number of turns secondary upon number of turns primary. What I need is number of turns secondary. So I can rewrite it as number of turns secondary is equal to EMF secondary, which is 11,000 volt, upon EMF primary, which is 220 volt, multiplied by number of turns in primary, that is 100. Now this will turn out to be, if I take 110, this is 5, so basically it is 50. This gives me 5,000 turns. So to step up the voltage from 220 volt to 11,000 volt with 100 turns in the primary, we need 5,000 turns in the secondary coil. Second case, since we are stepping down the voltage, obviously the secondary coil will have lesser number of turns. Let us calculate it. Again the same formula, EMF secondary upon EMF primary is equal to number of turns secondary upon number of turns primary. What I need to find is the number of turns secondary. That will be EMF secondary, which is 22 volts, upon EMF primary 220 volts, multiplied by number of primary turns, which is 100, and that will give me a 10. Therefore, in the second case, where we are stepping down to 22 volt from 220 volt, we will need 10 turns, provided there are 100 turns in the primary side. Okay, so this gives you a complete insight about transformer and how this is an application of electromagnetic induction. This was last topic in our discussion for electromagnetic induction. Next lecture we'll start a new chapter, and that chapter will be basically discussion on thermionic emissions and radioactivity. So I hope to see you in the next class. Till then, have a great day. Goodbye.